Today we're going to look at the subtraction problem 2x plus y over 6xy minus x minus 3y over 4xy. So first we have subtraction. So that's always one of the first things we want to make sure we identify. That's a subtraction problem. So in that case, since it's a subtraction problem, we want to get the denominators the same. So we want an LCD, a least common denominator. So looking at 6xy and 4xy, they both already have xy. So I don't have to worry about anything there. But I do have to worry about the 6 and the 4. So thinking about a least common denominator, I want to think of multiples, 4 of 6. So 4 doesn't go into 6. 6 goes into 12. 4 goes into 12. 4 goes into 8, but 6 doesn't go into 8. But 4 goes into 12. 6 goes into 12. So that means I want my denominators to be 12xy. So I'm going to do whatever I have to do to each fraction in order to get that denominator as 12xy. So in this one, I'm going to multiply by 2, because 6 times 2 is 12. And then this one, I'm going to multiply by 2. Careful here. Make sure you are representing that as times 2. That whole statement needs to be multiplied by 2. And then over here, I'm going to multiply this by 3, because 3 times 4 is 12. And then this whole statement needs to be multiplied by 3. So remember, when we are doing addition and subtraction of rational expressions, we want to make sure that like when we're changing that denominator and we change the top also, that's because we're just changing the visual of it. We don't want to actually change the value of the problem. We just want to change the visual. So multiplying both of them by 2 are really just moving in place, almost like running in place. Like you're changing something, but it's not actually doing anything. It's not actually accomplishing anything other than changing the visual, which then allows us to take a couple more steps. So I'm going to distribute the 2. 2 times 2 is 4x plus 2 times y is 2y over 12xy. I'm going to go ahead and just extend this out now. So here's where we have to think though, because I'm doing 3 times x and then 3 times negative 3y, but it's being subtracted. So I could do this in 2 steps. I can distribute the 3 and then distribute the negative back, or I could think of this as negative 3 times x minus 3y, which is then going to be negative 3 times x. Negative 3 times negative 3y. So it's distributing the negative 3. So negative 3 times x is negative 3x. Then negative 3 times negative 3y is going to be positive 9y. Because you're doing negative 3 times negative 3. Now again, you could have done 3 times x, which is 3x. 3 times negative 3 is negative 9y. But then you'd have this subtraction here. So you'd have to subtract off that whole entire statement. So that's something that a lot of people miss right there. That whole sequence of distributing the 3 and then making sure you want to distribute that negative back into there. So easy miss there. So you got to be careful with that one. All right, now we just have some simplifying that we can do. So I have 4x minus 3x is 1x. I have 2y and 9y. Those are like terms. So 2y plus 9y is going to be 11y. And then we have that all over 12xy. I don't have anything that could simplify out or anything like that. So that would be my answer. X plus 11y over 12xy. So the key here is finding that least common denominator. And then more importantly, this whole sequence. This distributing the negative 3. Because we're doing 3 times that, but it's being subtracted. So we want to make sure we distribute a negative. If this was addition, we don't really have to understand that because we would just know we're going to distribute to the 3, and then you might not even pay attention to that sign. So if it's addition, you could accidentally get the right answer. But when it's subtraction, you want to make sure you're careful on that. So there it is.